Okay guys, this is our first video. Try it out, see how this goes. This is to be your lesson on how to calculate a theoretical yield and compare that with an actual yield, and then ultimately calculate a percentage yield. So we're going to jump right into this example problem where you see it says calculate the theoretical yield of C2H5Cl if 112 grams of C2H5OH is reacted with 34.7 grams of PCl3 based on the reaction below, right here. Look at that. And then this part, if 23.7 grams is produced, what is the percent yield? This is going to be for later. We're going to come back to this one. So let's start the first part of the question. Ultimately, we see we have 112 grams of C2H5OH is reacting. So let's go ahead and put that in here. 112 grams. And then we also have 34.7 grams of PCl3. So we'll put this in here. 34.7 grams. So the thing we need to do is first find out what our limiting reagent is. Okay, and so remember to do that, we're going to convert. Right, so convert grams into moles. Remember, when in doubt, pull it out. Okay, so we're going to take 112 grams of C2H5OH. Okay, so we're going to divide by the molar mass, which is 46.07 grams per mole of C2H5OH. Okay, and that's going to give us 2.43 moles of your ethanol, so 2H5OH. Okay, and then I'm just going to continue on over here for the other one. So then we're going to take 34.7 grams of phosphorus trichloride, PCl3. That molar mass is 137.3 grams per mole. So that one would give us 0.253 moles of PCl3. Now remember, this is saying this is how much we have of PCl3. And just like over here, this is saying again also how much we have of ethanol, right? C2H5OH. So now we're going to just take one and convert it to moles of the other. So let's go ahead and just convert. Let's do the moles of the phosphorus trichloride, let's say, into the ethanol so that you can have a comparison. Okay, so let's take this amount of moles, right? .253 moles of PCl3. I'm going to multiply it by a ratio, right? Remember your ratios, here are these coefficients, okay? So multiply by 3 moles of ethanol for every 1 mole phosphorus trichloride, and that's going to give us 0.759 moles of, of ethanol. Okay, so this is saying how much we would need of ethanol. Well, if we need 0.759 and we have 2.43, then we have way more than we need, right? So that tells us that phosphorus trichloride is going to be our limiting reactant, and then of course that means ethanol is our excess reactant, right? Because we need so much less. Okay, so now that we have that, okay, let's go back up to the problem. Let's look at what we're trying to do here. So we're trying to figure out the theoretical yield, okay, of this product, right? So that's what we're trying to get to here. This theoretical yield. Hey, that didn't work out the way I wanted it to. You guys are having fun with these videos, huh? All right, so let's try the theoretical yield of our product, okay? Which this really means, what this is saying is the grams produced, okay? So let's go back down, let's look at what we've got here. Okay, so we're going to take our limiting reactant, right, our moles of our limiting reactant here, okay? Okay, so let's try to change it up here. So we're going to take the moles of our limiting reactant, so our 0.253 moles of PCl3, okay? And we're going to convert it into moles of the product. So let's go back and look at that equation. Okay. So here we have, this is the product that we're looking for, right? C2H5Cl. We've got a ratio of 3 to really 1, right? So let's go ahead and add that in there. Okay, so we're going to have 3 moles of C2H5Cl for every 1 mole of phosphorus trichloride, right? And that's going to give you 0.759 moles of your product. But remember, we're trying to get to grams of that product. So we're going to take this amount in moles, multiply it by the molar mass, 64.51 grams per mole. The molar mass of that C2H5Cl, and then that's going to tell us we have 49.1 grams of C2H5Cl. Okay, oops, what was that invisible link there? Okay, so 49.1 grams. Okay, so that's our first answer. bearing with me as I practice this with my guinea pigs. Okay, so that's the first part of the question. Okay, so we're going to go back up here. You can see it's this theoretical yield right here. Okay, this theoretical yield of the C2H5Cl. This really was what we were looking for, right? So that we found it. It's 49.1 grams. That's the theoretical yield. So now we can go to the second question. The second question, what is the percent yield? Okay, so here we are. It's later. We're going to do that now. So you need to understand the equation for percent yield, which is simply that percent yield equals the actual yield divided by the theoretical yield. That whole thing is just simply multiplied by 100. Okay, so let's fill in what we got here. This percent yield that we're solving for, okay, let's look up the question. It says right here, if 23 grams of C2H5Cl is produced, for this 23.7 grams, this is the actual yield. This is saying it's actually produced, the actual yield, right? This way. Okay, so 23.7 grams of C2H5Cl, that's what's produced, divided by the theoretical, what we just figured out, 49.1 grams of C2H5Cl. That whole thing multiplied by 100, and you get 48.3%. Dun, dun, dun. That is your percent yield. And you are done. And that was it. That's the lesson on how to calculate theoretical and percent yields and compare them with actual yields. Okay, guys, I hope this worked out well. Bye-bye.